Good day, ladies and gentlemen, and welcome to this GeoChat session. Today, we'll be talking drones. We have our guests. You know, before I used to know his name, I just used to call him the drone boy. So he's here with us today. I'm not going to be introducing his name. I'll leave that time for him to introduce himself. And my name is Belinda Mavu, and I'm the president for Zimbabwe Institute of Geomatics Youth Network. So for now, I'll leave this moment to Mr. Drone to introduce himself. Over to you, Say.
Thank you, Belinda. Thank you for this opportunity to speak about drones and just to shed more light on what's happening as far as I know in the drone industry, specifically in Zimbabwe, and what opportunities lie in the industry for geomaticians. Maybe first of all, just checking. I hope I'm quite audible.
Yes, you are, Say.
Right, perfect. So maybe to just introduce myself. My name is Tatenda Mafara, formerly known as Tatenda Mafara, or Sasha rather, and well, within the drone space as drone boy. So currently I am the general manager for Ironmask Aerotech. Ironmask Aerotech is quite a new company, properly registered in Zimbabwe, that's specializing in the use of drones, specifically for survey-related work and mineral exploration as well. So we started personally, I started the drone journey right about 2017. Then we only had to start Ironmask this year. So we are only 8 months old. And well, we are pushing, hopefully we'll be counting the years to come. So, well, that's it in terms of introducing myself. I hope that was clear enough.
Yes, thank you very much. This is quite interesting. We have a big man on the platform today, and we hope to learn more from you. So I think we should just get right on the business, okay? First thing, before we even go any further, I know that we know that the drone technology is I would want to say the drones, they are the emerging technology. They are the new thing that is all over, that is penetrating many industries. You find this drone in the media, drone everywhere, even in the geomatics sector. And I'm pretty much sure that a lot of people, they've just heard about drones all over. But maybe there's somebody here who doesn't really know what a drone is. So my very first question is, what is a drone? Can you shed more light on that? What does it look like? What, and also how does it work? What types of cameras and sensors can a drone carry?
Okay, all right, that's a very broad question, but maybe to start off, a drone is basically a remotely piloted aircraft system, right? And it's unmanned, meaning there is no human being who's actually on board the drone to actually pilot it around. So you are piloting the aircraft from the ground, which means that you definitely would need what they call a ground station, where you're actually operating the aircraft from. And from the ground station, there is now communication between yourself and the aircraft when it's in the air. So it's basically an aircraft small enough to be flown around, you know, even within tight spaces sometimes, and also large enough to be able to carry certain payload. So in this instance, when we are looking at the surveying industry, we are talking about payloads like cameras, right? Cameras, the normal optical cameras that we know, where, you know, you can just, it's RGB, right? Red, green, blue. Then you can also be having LiDAR payloads, where you are now carrying sensors that detect light. That's the light light detecting and ranging system. Then you can also have sensors for multispectral cameras, where you're now capturing images and scenes within the other spectrum outside of the visible spectrum. So then of late, I think we now have sensor payloads that can detect magnetic variations in the earth, which are the ones that we are using for our mineral exploration. Then there is also now ground penetrating radar. So the type of sensors that you can carry on the aircraft is it's now vast. I think the only limitation in the drone technology competing with satellite imagery is now to do with the size of sensors that are there already. Like for instance, if you're talking about hyperspectral, the science for hyperspectral sensors has not been refined very well for it to be carried on a drone. So at the moment, it's still effective on satellites. And so basically, that's what it is. You're looking at an aircraft that is being piloted remotely, whether from a ground or from any other platform. You can even pilot it from a vehicle, right? Then that aircraft has the capability of carrying sensors in the visible spectrum, the magnetics sensors, the ground penetrating radar sensors. Yeah, basically, so that's what a drone is. And I've got a very popular drone that I have. Most people know it, whether I've been to weddings or not. So this is the aircraft. So this is a Phantom 4 Pro, all right? It has a camera. This is for the visible spectrum. So the normal RGB cameras where you take your videos and the pictures. So that's the one. So in terms of classification, this would be classified as a quadcopter, right? Because of the 4 propellers that it has. So you can have all types of, copters, whether it's one, which is a helicopter. So there are drones which are helicopters with 1 propeller, 2 propellers, 3 propellers, even up to 10 propellers, depending on how big the aircraft has to be. So like for instance, the one that's behind me, that's a hexacopter, popularly known as a Matrice 600. But the signs and how they fly also depends on the structure of the aircraft. So you also have fixed wing aircrafts, which basically operate similarly to a plane, the normal commercial planes that we normally board, right? Those base their signs of flying based off of the wing technology, aerodynamics. These ones are mostly to do with propellers and blades, taking off and landing. Then we also have another class of drones, which is called vertical takeoff and landing, which is more of a blend between a fixed wing and a copter, right? So it takes off like a copter, which is vertically taking off. But when it's now flying, to ensure that it flies longer, it now uses the flight principles of a fixed wing aircraft. So maybe in summary, that's what a drone is. And those are basically the types of drones that they are. Fixed wing, copters, and the vertical takeoff and landing, which are normally called the hybrids.
Oh, wow. Well, we are learning, ladies and gentlemen. I hope you have your notepad somewhere and you are busy taking notes. He's just gone through defining what a drone is, and I've picked up 1 or 2. So my next question is, what is the current status quo for the drones in Zimbabwe? Can you tell us, can you talk about the drone revolution in Zimbabwe?
Okay. Well, basically, I think people are actually quite excited about the technology, all right? There's been so much happening with regards to the drone industry in Zimbabwe, which is actually quite commendable. Just a few years back, it was really difficult for you to be operating an aircraft in Zimbabwe because of the privacy and the security threats that the technology also brings, right? So there was not much information around how to curb, the threat of drones evading privacy, and breaching security where they are not supposed to be flown. So the one rule that was there was that drones are not even supposed to be flying in Zimbabwe, right? That was before we had our regulations in. But the government of Zimbabwe has done so much work around the drone regulations, and they managed to publish the regulations in 2018 to say now you can fly your aircraft, but you need to follow the rules that are within that regulation in terms of how you're going to be operating and where you're going to be operating the aircraft from. So we have seen quite a significant growth in acceptance in private sector, in public sectors as well. And of late, I'm sure most of you might actually know that there was the first drone conference that was hosted by Precision Aerial just a few weeks back, which is quite a milestone. And at that conference, there was the opportunity to shed more light on what the technology is and what it's bringing to the table. And we saw so many organizations, both parastatals and private, coming in to register and also to appreciate what the technology brings. So what it says, it means that people are learning about drones out there, right? They're learning about the capabilities of drones, and they're also learning about how to integrate the drone technology within their companies. All right. So I can safely say there is some significant growth in the industry, and there is quite some acceptance around the use of drones, and people are not really scared about drones anymore. What I was talking about, to say people were scared about drones evading their privacy, drones being misused for misacts, right? But I think now that we've got regulations in place, people are now able to be using the drones in the appropriate way without abusing them. So yeah, I think Zimbabwe is on the right path in introducing drones. But in terms of the sectors that have actually accepted drones, I think geomaticians have taken a step forward in actually adopting the technology for reasons, several reasons: ease of work, quality of data, addition of value in terms of geospatial data that you can actually collect from the drones. And I think where we are seeing a bit of lagging behind is the humanitarian use of drones, in delivery of medicines, delivery of parcels, and all those other economical use of drones. But with regards to geomaticians, yeah, I think people are warming up to the idea of using drones.
Oh, thank you. You mentioned something that is quite interesting. You mentioned delivery of parcels. Can you take me through how you think this can actually be practiced? Like, how is it going to be looking like?
Okay.
Delivery of parcels day to day, door to door, or?
Okay, yeah. Basically, it's they call it the last mile delivery. Okay, where you can have a parcel coming from, let's say from South Africa, right? Aboard the normal freight methods that we're used to, okay, via road, even via rail, But when you eventually want a parcel to get to the individual in their own personal space, that's when you now have delivery guys with the motorbikes, even the small cars, even by foot, right? So the drones are now being implemented for the last mile, the last stage of deliveries that needs to be done that's in other countries. The European, the Americans have already introduced that. And I think with regards to where it's actually being used effectively now, Rwanda has been the guys who have led this revolution in terms of using drones for deliveries, and how they're implementing it, because you want to have a system that's efficient, a system that actually delivers results. It means you need long endurance aircraft that can be able to carry heavier payloads, right? You don't want to be going all the way to Mutare with an aircraft that's only capable of carrying, 500 grams, it means you can probably only be able to deliver a packet of Maputi to Mutare, right? It doesn't really make sense for you to use that very expensive system to deliver, something of that value. So it's only now that we have had aircraft that can travel 200 kilometers beyond visual line of sight, from one takeoff point, and be able to carry cargo as big as 100 kgs, right? But there are so many complexities that come with such a system, right? One is you're operating the aircraft beyond visual line of sight. You don't get to see the aircraft, right? So it means when you're not seeing it, you're not able to evade some of the hazards that come with, flying beyond visual line of sight. You are prone to meeting other aircraft in the air, and you are not even able to see it. Okay. You are not even able to actually control the aircraft as efficiently as you would have done if you were seeing the aircraft. So the fact that you're flying to deliver beyond where you can see, it brings in a complex situation in terms of flying. And regulations also need to be put in place to be able to govern how you're going to be operating those aircrafts. That's one. Then two, there's the issue of the system itself being able to operate in beyond visual line of sight situation, where the aircraft needs to be in constant communication with the controller, right? So it means you need some form of telemetry that cannot be impeded, that cannot be tampered with, all right? That is able to communicate from 200 kilometers away. You are able to have, without drag, the instant position of the aircraft, the status of the aircraft, the battery, even how it's performing. You need to be knowing that. So the technology to be able to communicate with the aircraft also brings in, challenges in terms of development of systems that can actually deliver packet parcels. Then thirdly, you're also looking at you're looking at complications to do with the regulations themselves, right? The technology is moving so fast, and already we are lagging behind on regulations, because our regulations were only introduced in 2018 when the technology was introduced 10 years back, right? So we've got an 8-year lag in terms of how our regulations are developed, right? So we need to be having a system where there's continuous revision of these regulations to allow and accommodate the changes in those spheres of the technology. So it's possible for it to be done, right? But they need to be systems in place to make sure that we have the adequate equipment, reliable equipment. We've got a reliable regulatory body that's obviously continuously revising the regulations, and also for us to have the space to be safe to operate it, because you don't want to be flying into an aircraft, right? So yeah, it can be done. Only those few challenges are the ones that are only hindering us from actually implementing those, those kind of technologies within Zimbabwe. But well, Rwanda, Malawi, Guinea, Ghana, Nigeria, they've introduced it. So what it means is we can also be able to do it.
Wow, this is quite interesting. So you mentioned drone regulations like maybe 3 or more times. I'm very much interested in these ones. Can you shed more light? Can you talk about the regulations? Do they only govern the usage of drones, or also they protect professions as well?
All right. Well, we cannot be talking about drones without talking about regulations, because if there is any industry that's really that really pays attention to safety, it's aviation. All right. Even the medical field probably takes a leaf from aviation in terms of safety and security in terms of how you get to use equipment, right? So when we're operating drones, there's a lot of things that come with it, like I mentioned before: security, privacy, and safety, right? So the regulations that have been developed, these were drafted and released in 2018. okay? And they are trying to address a situation whereby we have people flying drones willy-nilly without any respect for the law, right? So they talk to how drones are supposed to be flown, where they are supposed to be flown and where they are not supposed to be flown, all right? And who should be flying those drones. So it's basically who, where, and how you're supposed to be flying these drones. So our regulations have allowed us to be able to fly the drones, okay? But they are also limiting in terms of how and where you can be flying these. And this brings about a challenge, because it means when you are, I'll give you an example, right? One of the points that are in the regulations are that you are not supposed to be flying an aircraft above 400 feet. 400 feet, you're probably looking at 120 meters above ground, okay? Why they say so is because above 400 feet, you are now within manned aircraft airspace, right? You're most likely going to be meeting the helicopters, the bush planes, you know, even gliders, right, above 400 feet. So in terms of safety, that law it's quite it's quite good, because it avoids you having to crash into any aircraft. But what it also means, it means with the systems that we have available, you will not be able to fly your aircraft 500 meters, which allows you to have wider coverage in terms of covering for geomaticians if you're going to be doing any flight to collect spatial data. The higher you go, the more coverage in terms of area that you'll be able to do. So it means already you've got a ceiling in terms of how much you will be able to fly within a given period of time. All right. So there's also need for us to revisit those regulations to see at what point a pilot can be able to fly above 400 feet. All right. Those regulations were drafted in let's say we probably got those regulations from South Africa. We took a leaf from South Africa, right? But the South African airspace is already busier, probably 15, 20 times busier than the Zimbabwean airspace, all right? So sometimes just getting laws that are coming from a different country to just bring them into Zim also becomes a challenge, because they can get away with flying below 400 feet because there's higher chance of you interacting with manned aircraft. But then in Zimbabwe, it's different. So that's just an example of a situation where a law can be limiting, but at the same time is addressing certain concerns, all right? So with regards to our regulations now, I can say the civil aviation really did quite good work, because it takes a lot of time for you to bring together that kind of document. I'm sure the Zimbabwe geomatics industry, you can also allude to the fact that it's not easy for you to eventually have a bill, right? A document that's addressing all those things, right? So civil aviation, they've actually done really good in bringing up those regulations, but that's a start, right? I think now we need to look into engaging the regulators and the industry, right? Start having discussions on how and where we can refine those regulations to make it easier for the industry to work, right? But well, I think we are on the right path in terms of where we are going with our regulations. It's now just a matter of the interaction and refining of regulations.
Thank you very much. That was very clear. So now we move on to the next question. I would like you to give us examples of applications of drones, the drone technology. Already you've mentioned parcel delivery, but maybe somebody who is joined this platform and they are really interested in drones and they don't know where to fit. They just have heard about drones, like it's all over, it's the news all over, but they want to know where to fit. What are the possible opportunities that drone technology is presenting?
Okay. So I think your question has 2 points, all right? We've got one side on application. of the drone technology, all right?
Yes.
When you're operating a drone, where can we apply the technology in terms of industry, use cases of the drones? Then there is the other part of the question where you're talking about where people can fit in within the drone industry. So basically now we are talking about the drone ecology, the industries that are surrounding and that are influenced by this technology. All right. So I'll probably start with the industries because it's a bit broader. All right. So the technology already, it has introduced a new ecosystem, right? It has introduced new jobs where there was no job regarded as a remote pilot, right? Now there's a job for a remote pilot, right? Someone who has the skill to actually operate the aircraft. Then there's a job that has come in with actually manufacturing the drones, right? Being able to manufacture the drone, then also being able to maintain the drones, right? So already we've got two industries where you are operating the aircraft and where you are manufacturing the aircraft, right? And maintaining the aircraft. So anybody can fit into the operation of the aircraft. Someone can fit into the manufacturing. So we've got electro engineers, electronics engineers, mechatronics engineers that are now having new work to do, right? In terms of development of these aircraft, right? Then there's the industry of retailing, buying and selling of the equipment, right? Already in Zimbabwe, unfortunately, we do not have, institutions that are actually building commercial grade aircraft. We've got, I think, Areal Institute of Technology, Chinwe University of Technology, that have managed to develop a drone, but still they're in the stages of refining it for it to be able to be classified as a commercially viable aircraft where people can actually go into a shop and buy it, right? Produce it large scale for people to have spares, and all that kind of system, right? So what it means is we're still in a position where we still need to buy these aircraft from outside, whether it's South Africa or China or even the Americas, we still need to be purchasing these drones. So there is that opportunity for people to venture into the drone industry, but as a retailer, right? They're buying and selling the equipment and the spares. Then we also have, within the industry, you can have service providers. Now we are having those guys who are using the drones for different applications, all right? Applications like drone deliveries, applications like aerial surveying and mapping, applications like exploration, right? All those different applications now, we've got people who are providing the service, based off of the technology, right? So we've got operators, right? Remote pilots, we've got manufacturers, we've got retailers, we've got service providers, right? Then another industry that is taking stage, especially in Zimbabwe, is in the finance and banking side, right? Because this is now an industry where, there's so much value that's coming from it and people are actually, buying into the technology. It means there is an opportunity for financiers and bankers to invest in the industry, right? So we can actually have people, who have no engineering background, right? But, they're in the finance, the money guys. Now they are able to also be playing a part in the industry as well. So finance and banking are coming in to fund the technology. They're also coming in as insurers, right? We now have drone insurance. They already had insurance for aviation aircraft, but now this is a whole new industry that's coming up. So you've got people who are now introducing drone insurance for the players that are in the drone industry. So we've got various entities that are now popping up just from the drones being there. Okay, so in terms of where people can fit in, you can have people of various professional qualifications, whether you're an accountant, right? You're also coming into a company that is dealing with drones and you're managing their accounts. Whether you're an auditor, you're now coming in to audit the equipment, the same thing, but then it's now different because it's now based on the drone industry. All right. Then we've got the mechanical guys coming in to fix it. So the ecology itself is growing and it's limitless, right? You can introduce several professions just around the aircrafts. All right. Then now to probably respond on the issue of application of the aircraft, that also is quite a broad question, but like I initially highlighted, there is humanitarian use, drone delivery, and last mile deliveries. There is aerial surveying and mapping, which I assume most people here are interested in knowing, so I'll probably elaborate on that. There is, you're looking at exploration, right, where you are attaching different sensors on the aircraft to be able to collect information that relates to mineral exploration, okay? Then there is also the issue of not just deliveries, but transportation. Of late, we have countries like Dubai, where you actually have people who are using what they call drone taxis. Okay, they're applying the aircrafts in terms of commuting up and down as well. Then several other applications, but I'm sure I won't be able to exhaust that. But out of interest, knowing that we've got geomatics following, especially within this GeoChat session, I'll probably just expand on the applications within the aerial surveying and mapping side. So because now we've got a tool that's able to collect spatial data at amazing accuracies and amazing detail, right? It means now we are able to do what we initially were able to do before with our GPSs, with our total stations, but now we are now able to do it on drones. So when you attach a camera on a drone, right, it means you are able to collect aerial images. What we used to do as photogrammetry, analog photogrammetry with manned aircraft, we are now doing it with drones, but now it's digital photogrammetry, right? So we are flying and collecting images. From those images, now after post-processing, you are now able to collect, to give outputs such as high resolution orthomosaics, right? That's a composite image, that's a stitched together image of individual images that you have brought together to create one Google Earth image, all right? Which is really, really high resolution, up to 1.5 centimeters of pixel size. It means you are actually able to detect something as small as a mouse when you're flying as low as that, all right? You are able to do 3D models. Through structure from motion, you can be able to generate a 3D model, right, of a digital twin, rather, of the surface that you're mapping, right? And obviously, when you're having the 3D model, it means you can do several applications from those models. You can do your contour mapping, your topographical mapping. You can do your volumetric assessments of pits and piles, right? Because they're 3D and they're measurable and they're very accurate, right? Because the GPS system on the aircraft as well, we now have RTK and everything. It means it's more accurate. So you can do all those kind of measurements and deduct all those kind of insights from the data. So you're looking at aerial mapping, which are the orthomosaics. You're looking at topographical surveys, which are commonly vector files, right? Contours, roads, buildings, that's your topographical feature map, okay? You're also able to do your volumetric assessment, whether it's indoors or outdoors, provided there's space for you to be flying indoors. You're also able to do your underground mapping of your tunnels, right? Your stop assessments, you're trying to do the assessments to see if there is any chance of landslides, those kind of things. So anything that relates to spatial data manipulation and management, you are now able to do it from a drone. Hopefully I managed to clear it out.
Yes.
Sure.
Yes, thank you. You were talking about surveys, right? From my point as somebody who is in the survey sector, I'm very much interested in the issue of accuracy.
Okay.
I mean, how can we really say that we can actually use a drone and achieve our task, to the maximum or highest accuracy possible? It doesn't have a relationship, the flying height, or maybe the type of drone. Does it have a relationship to, the accuracy?
Oh, yes, actually it does. And well, like any surveying or geomatics principle, right? in terms of accuracies, it depends with your need, right? We've got all these different branches of surveying and geomatics that are there. We've got the cadastral bit, we've got the engineering survey bit, right? We've got the mining survey bit. All those have got different accuracy requirements, right? That's why we also have all those different grades in terms of, like for instance, if I'm flying for a farm survey, right? It's the accuracies that I need for that survey are way different from the accuracies that I need for a cadastral survey standard map, all right? So what it means is, depending on the end use of the data that you're collecting, you also need to assess the accuracies that are required. But what it means, it also means you need to refine your processes of data collection, right? How you're actually collecting the data, right? You need to be sure of the equipment that you are going to be using, right, to ensure that you get those accuracies. I'll elaborate on that. You also need to be sure of how you're going to be doing your data processing. So all those three stages actually affect your accuracies, right, eventually. So all those three stages, planning, data collection, and data processing, need to blend in with the end result in terms of accuracy that you need to do, okay? So just to give a simple example of how you get to decide on which kind of accuracies you need to do. When you're looking at an engineering grade survey for a road, okay, before a road is even there, you need to know your topography, you know, all the changes in the terrain that you are probably going to encounter when you're actually going to be putting the road there, okay? But that's in the design stage. When you're doing the design stage, you're not looking at millimeter accuracies, right? All you need are the profiles. Probably at most, at best, 5 to 10 centimeters is even it's an overkill, really, okay, when you're still on the planning stage. But what it also means is you need to be sure what your client wants or what the end user wants. Is it for planning? Is it for actual, erection of structures, right? Because now when you're looking at actual erection of structures, then it means your accuracies need to be really, really high. That's when you now have to decide which aircraft you need to be using. So when you're doing your design stage for a road, you just want to know the profiles. You want to know the features that are within the areas. You want to know the relationship between where you want to put the road and the cadastral boundaries, okay? You know, in not too serious accuracies, right? So you can get away with flying a Phantom 4 without RTK, right? You put in a few GCPs so that you still have your model within acceptable accuracies, acceptable engineering accuracies, right? Then you put your GCPs, you put your Phantom 4 there. Then you are now doing your processing, your data processing. You can get away with processing at let's say probably 5 to 10 centimeters resolution, okay? Then you give your client the topographical survey map, your aerial map, easy. It won't affect anything, okay? Then when it comes now to the stage where you want to actually now put the road on the ground, you're now putting the different layers, the gravel, the tar and everything. Those now come down to millimeter accuracies, okay? And at that point, you might find your drone might not be the best solution to use for people to do their height measurements, right? So in as much as we have the technology coming in to help with the processes of collecting spatial data, at some point, because of the accuracy requirements, you might find you still need to go back to your levels, right? As old as it is, it's still more effective, right? So that understanding to know the limitations of what your drone surveys can do and where to cut the line to say, I'm not going to be using a drone at this point, it's really necessary. That's why still when you're able to fly, when you're able to collect spatial data, that appreciation of the land survey principles, engineering survey principles is still necessary, Okay, so every Jack and Jill who can fly a drone cannot be the best person to be collecting spatial data, because those principles, they still don't understand them. All right. So with regards to accuracies, you need to consider the process, you need to consider the equipment, you need to consider the processing, how you're going to be processing the data. And to make it, to emphasize this point, there is that general excitement of using drones that people feel we now need to discard the old ways of, we can easily get away without a total station, we can get away without using a dumpy level, we can get away without using, even a GPS, because now the drones have got RTK, right? I think that's a bit short-sighted and narrow-mindedness, right? Because there is the issue of building spatial data. Spatial data has been collected for years and years now. The Surveyor General's Department has got maps from long back. We've got our national trigonometrical system that was erected long back, and all the other information that we have been using thus far has been based off of those national trigonometrical system, right? So what it means is we've got so much spatial data from years back that we still need to integrate with the new data that we are now collecting with the drones, okay? So what it means is we need to bridge that gap and have people who are actually merging the two information that are now coming up, the new and the old. And that overlap now, it can only be it can only happen when we still observe the old ways of doing survey work and bring in the new ways, but then blend them together. So basically what it means is we need to review our processes, how we are collecting our data and how data was being collected before. Where we were having regulations that speak to collecting data using total stations, we now need regulations that speak to collecting data using the GPS and using the drones. That's how best we can be able now to integrate the data to ensure that we maintain those accuracy standards that we are so proud of speaking about when we are talking to geomaticians. Surveyors, we always want to speak about how accurate our data is. So that blend needs to be addressed in our regulations.
Okay, it looks like you have actually partly answered the next point that I was going to mention. There's this question that people have been mumbling in the survey, and rather, let's just say the geomatics streets, whereby they are worried whether the drone technology has come to take over their industry. Can you comment on that one?
Well, I wouldn't say it's coming to take over the industry, because the industry is still there. The industry is just evolving, okay? Yes. Probably the best way to put it is there is the fear of de-skilling. And what de-skilling is the rendering of certain skills to be obsolete, right? Where you were very good at using your total station, right? Your bearings, your orientations, right? Your ranging, and I don't know, the setting up of the tripod, right? Where you were really good at that, the drones coming in, it introduces a whole dimension where people feel now our skills of, being able to hammer in a peg are not needed anymore. Our skills to be able to, collect data using a total station are not needed anymore. But I think any industry is really changing. And we have not been left out in terms of change. The technology has changed. The data needs have changed. The needs, really, what the client wants. They don't need just coordinates of beacons anymore. They need it, but it's not enough anymore to just know the coordinates of your boundary, okay? Now they also need to appreciate, to have a visual appreciation of what's actually sitting on their land, right? You go into Epworth, okay? You want to regularize Epworth. It's not enough for you to be just having, those cadastral corners without knowing what exactly is sitting within those cadastral corners. and you have people who are not as talented to be able to interpret lines and points and text, right? If you give a normal person our general plan, you might find they might have struggle interpreting which one is the road, okay? Which one is which one is an industrial stand and which one is a residential. It's easy for us because we've learned it, we've gone to school for it, but some of the decision makers, the people who are actually depending on the information that we're providing, sometimes they just love to see colors. They just love to see something that they can relate to, all right? So it's easy for them to now decide, okay, I'm going to put money into the regularization of Epworth because they've seen from an aerial view, they've seen that, these houses are spread all over. It's not regular, it's not structured. So it's easy for them now to say, no, I'll probably put money into this project because they now appreciate it, okay? So for people who are feeling as if the technology has come into, to render them, for a lack of a better word, to render them useless, I don't think that's the case. I think the drones, they've just come in to add value to what we already had. It's now up to us to adopt the technology, right? Be the leaders of the use of drones and make sure anybody else who's coming into the geomatic space, they still respect us, because now we are having people who come from several other industries because they can fly a drone, okay? You can go on YouTube, you can watch a video on how to collect data using a drone. It's information that's all over the internet, right? But those people, like I said, they don't have that background understanding of land survey principles, why it's necessary for data to be accurate, okay? So in the end, they compromise, the whole survey and geomatic space because, they're just coming in to do it. But because there are no geomaticians who are actively coming in to advocate for the use of the drones, to advocate for standards and regulations in terms of the use of the drones, no, they can get away with it. And next time a client or anybody who gets data that's done substandardly by someone who has a drone but is not a land surveyor, they get bad data. The next thing is they are saying, this drone business doesn't work. Drones are not accurate. Drones do not have good data because they got the data from someone who's not professional, right? So it's now up to us as land surveyors, right? Both the older generation, the new guys who are coming from the university and everything, it's now up to us to advocate for the adoption of this technology, for policing of this technology, to protect both our industry and to protect even the client, because clients are being duped. They get data that's off by 1.5 meters. They plan on it, you put millions into it for planning, you lose millions because now the data is off. But what do they say? They say the drones do not work. They say these geomaticians do not work, whereas we are not standing up for ourselves, right? So I feel it's not about de-skilling. It's not about rendering the other older guys or people who are used to a certain way of doing things to render them useless. It's about them now adopting to going to the new technology and bringing in the skill that they know from backwards, from history or from their experience. Bring it in and make sure that it works, and it works for the new technology as well. So it's basically coming in to complement what's already there.
Wow, thank you so much. Too bad we have limited time, but that was quite enlightening. So before I leave the floor to the participants I think you participants can already start typing their questions on the chat box. Then we can hear what they want to ask and you'll be able to answer them. Whilst we are doing that, my last point is, can you take us through the process of getting the license, the RPL? What stages should one go through? What should we expect?
Okay. All right. Basically, what I said is we have regulations. Okay. Civil aviation released those regulations to make sure that they talk to who flies the drone, how they are going to fly the drone. Okay. And also what kind of drones are going to be flown, all right? So I think that question speaks to the idea of who is supposed to be flying a drone. So in terms of who, you can only be able to operate an aircraft in Zimbabwe, a drone, right, if you are a holder of a remote piloting license, all right? That's the Areal, all right? And that license is, you get it after going through, training on the laws that relate to flying an aircraft, right? You get it after going through the principles of how the aircraft works. You need to understand how the drone is flying for you to be able to, to troubleshoot or be able to maintain your aircraft, all right? So you also need to have an understanding of the kind of risks, right? And the hazards, whether it's weather, whether it's environment, whether it's human, the kind of risks that you're probably going to be, encountering, okay? You also need to understand issues relating to, what's that? Okay, navigation, okay? You need to be able to understand how to define where is north, where is south, where is west, okay? How do you orient yourself, and how do you know what direction an aircraft is flying? If someone tells you that I also have an aircraft and is heading 90 degrees south, you should be able to know that they are heading towards me, right? That kind of, and also communication. How do you communicate with someone when you're both flying in the same space, right? So those are the basic topics or principles that you need to understand before you are able to actually fly an aircraft. And when you understand those principles, it means now you are able to operate an aircraft in the aviation space, in the airspace. We can trust you to be safe. We can trust you to, to operate the aircrafts ethically, right? So that's the whole, that's everything that's covered in the REPL, okay? And that's what you're expected to know and understand by civil aviation. They expect you to know all that. And how to now get that, because the regulations state that you need it before you can fly. So if you're flying and you don't have it, basically you are flying illegally, okay? Well, it's unfortunate now we don't have systems in place that that are able to police and check if there's someone who's actually doing it illegally. But if you're unlucky, you get into a crash, you crash into an aircraft or anything, that's murder, right? It's almost like you're bumping into someone and you don't have a driver's license. That's murder, really, okay? So it's basically you having that license, it protects you from the law, right? Because we know that you're now operating in the standards that are expected, and the laws say you should have it. And for you to now get it, it's fortunate that now we have a training school in Zimbabwe that's offering the REPOs. You can just go and get the REPO from them. You have your training, I think it's just 2 weeks, right? Where you are now training how to operate an aircraft, how to interpret the laws. Yeah, it's probably 2 weeks. I think for a budget of 2,000 to 2.5, you can be able to get your REPO, all right? The only thing that I feel needs to be done more is to increase the time where someone actually operates the aircraft. 2 weeks is sufficient for you to, it's almost like a crash course, right? You have the basic understanding, but for you to also go through, actual flying, being able to evade emergencies, when you're in the field, it takes more experience, and that needs to be addressed, and people need also to have that experience, okay? But that only comes from you training from people who have actually experienced the whole flying experience. So then once you get your REPO, it means you can fly your aircraft, okay? But you cannot fly it for commercial reasons. You can fly it for leisure, go filming, go to Nyanga, you want to, capture some videos, if it's allowed in the national parks, you can fly it. But when you now want to operate that aircraft for the purposes of commercial grain, for profit, now you need what they call an ROC. That's a remote operator certificate. And that remote operator certificate, it speaks to which aircrafts you are supposed to be operating, okay? I come in as Tatenda to civil aviation, I need an ROC. I need to present my REPL, okay, to say that I can operate an aircraft. I also need to present what they call a letter of approval for my aircraft or a certificate of registration. So they need to be sure that the aircraft you are flying is, no, it's okay, it's well maintained, it's not faulty, right? So that letter of approval, it says that your drone is fit to be flying in the Zimbabwean airspace, right? Then you also need to get, well, once you get that ROC, it means that you can now operate commercially, right? You can operate your drone for commercial reasons, whether you are a company or a business that you just want to do your own in-house operations. Like for instance, let's say Daiwa Delivery, they want to introduce drones within their delivery space, okay? They also need an ROC, right? It's not to offer service, an external service, but it's for their own in-house work and everything. They still need an ROC, whether you're an NGO or in business. Okay, so for you to operate, you need an REPO for personal as an individual. Then you need an ROC if it's going to be for commercial reasons. Then that ROC, it will tell you who is supposed to fly within your company. Okay, you have a company of 5. It will say 3 of those people can fly, their names, right? Then it will also register the aircraft that they are supposed to fly. So if you bring in a new employee, it means you now have to update your ROC to say, I've got a new employee that I want to be flying as well, right? Then you need, if you bring in a new aircraft, you cannot fly that new aircraft before it is included in your ROC, all right? So that ROC speaks to the aircraft, it speaks to the people who can be able to operate your aircraft. And it also speaks to how you are going to be able to fly it. Are you going to be limited to flying your aircraft within 1,000 meters, or you are allowed to fly your aircraft from Harare to Mtara, right? So all those things are addressed in the ROC. I hope I've answered to say what you need for you to be able to fly. But to get the ROC, it's a process. Civil aviation will be the ones to determine whether you have passed. It's almost like if you're selling alcohol, you need a liquor license, right? So for you to operate drones as well, you need an ROC. But that you will be awarded by civil aviation after going through all the examinations and assessments to see that you are capable of doing it.
Okay, thank you very much, sir. I don't know how much time do we have. Is it strictly 1 hour, or maybe we can just overlay to, because there are so many questions that I have here. And
okay, I think we can push a little bit. We'll see how it's going, but yeah, let's proceed.
Okay, so somebody had asked about this ROC. The question was reading, or actually you have answered like part of the question. So, but I'll just read the whole question so that you get to answer them on what is missing.
Okay.
So the question was, is there need to have an air service license and operator's certificate on top of the pilot license to utilize drones commercially?
Okay. All right. I wouldn't want you guys to quote me on this one, because those kind of questions are really best answered by civil aviation. All right. Maybe at some point we'll have those guys also presenting and talking about all those regulatory requirements. But yes, you need an air service permit to be able to operate. But okay, I think I won't be the best person to respond this one. But yeah, obviously Ministry of Transport needs to give you that permit. But they are still working on how it's supposed to be handed out to whoever is going to be operating and how in Zimbabwe. So the space so far in Zimbabwe, because we are still putting up structures that help us fly that help us fly legally. The structures are still coming up, some things are still a bit shadowy and stuff. Certain ministries are also, they haven't really gotten into the drone space a lot. So even Ministry of Transport is still lagging behind with regards to handing out of these air service licenses. But on paper, the regulations say you would need to have that air service license. But because we are still building the structure, civil aviation, after they give you the ROC, they'll give you a special permit to say you can fly, right? Before you get the air service license, but you can fly 1, 2, 3 things. Or they will tell you, no, we have given you this ROC, but you won't be able to fly until you get the air service permit. So it's still something that depends on the assessment of civil aviation to say, yes, we can give you, or no, we won't be giving you. I hope I have answered. But then the best people to respond to that would be civil aviation. But on paper, you need it, the air service license. But depending on whether you meet certain criteria with civil aviation, they can allow you to fly without the air service, or they can refuse for you to fly without the air service license. But well, that's subject to discussion with CAS.
Okay. I can see more questions there popping up on the chat box. So here's the next question. It reads, are there open source software for post-processing drone data? On this one, I'll just combine it with another question that somebody had texted in my inbox. I would want you to tell us about software from fieldwork. Is there any software for specific tasks? What types of software do you use for post-processing and formulation of 3D models?
Okay. I'll be very careful with responding to that one. All right. In an attempt to also avoid sharing what we call intellectual property for ourselves. All right. But in the industry also getting people to develop, to produce data which is of good quality, that doesn't bring shame to the industry. Okay, the full process of data collection in terms of drones, it starts in the office. All right, you're starting in the office for your planning, right? This is how I'm going to execute my flights in the field, right? Then from planning, you go on to actual data collection, which is actual flying of the aircraft, right? Then from flying, you're now coming in to do the data processing. Of which the data processing depends on what outputs you want to get. All right. So on the planning stage, right, because if you're going to be collecting the data, you also, it's going to be autonomous, right? The drone is going to be flying by itself, right? Which means you have to define the path that is going to be flying pre-flight, right? So you're in the office, then you define where it's going to be flying and how it's going to be flying, what height it's going to be flying, right? And what direction it's going to be flying, right? So for that kind of planning, you can use systems like Pix4D capture, all right? Well, you can go and look out for them, see how best to go about it. You can look for Pix4D capture. It does the work really well. There is what they call drone deploy, right? It's also a really good software for your flight planning and even for your actual aerial data capture. Then there's DJI Terra. Okay, most of the drones that we operate, because in Zimbabwe, what I've noticed are either fixed wing EBs. These are from SenseFly, or they are the DJI brand, the Phantoms, the Matrix, the Mavics, right? Or some are warming up to be using the Wingtra drones. Yeah, we have some of those in Zimbabwe, but most people are using the DJI one. So if you have the DJI one, you can get away with using what they call DJI Terra. All right, that's for your flight planning and even for your aerial data capture. So you plan in that software, then you use the same software to fly in the field. Okay, So when you use that software to fly in the field, now you come back to processing the data. Now you have your images. For your orthomosaic mapping, right, and creation of digital surface models and DTMs, and possibly point clouds generation as well, you are looking at softwares like Agisoft Photoscan, right? There is Agisoft Metashape. Then there is also Datumate. Then you've got 3D survey, right? And the popular one, the Pix4D, right? I'm sure everybody knows Pix4D, right? Because that's the popular one. Right? So those, I think I mentioned 5 softwares. Those 5 softwares, they are paid for, right? And they are really good. What it means is I haven't come across an open source software that does data stitching. The best that I've gotten to using open source is getting trial licenses from these proprietary softwares. All right. There's a danger in using open source softwares, especially if you are producing data that needs to be used by engineers or by corporates, because open source softwares normally come with bugs, okay, where you might have an open source software telling you that you have an accuracy of 3 centimeters root mean square. It's very difficult for you to trust it, and it's very difficult for you to use that report and deliver it to a client, and they can actually depend on it, right? So I wouldn't advise on using open source softwares. If there is anybody who knows about that, maybe they can also share in the chat box. We can look into it and also see how good it's also generating the data as well. But it's good to be working with these paid softwares because they've been tried, they've been tested. There is support for those softwares, right? If you're going to be having any challenges, you can still go back to them to say, I paid for this software. Can you rectify 1, 2, 3 things? So you get support for a year, right? Even when you're trying to train on how to use the packages, you'll also be able to get that kind of training, right? So basically, those are the softwares that we would recommend to say you should go for, and for you to do your data processing.
Okay, I hope you have been answered. That was, I think that was Taonga's question. Now, moving on to the next question, it reads, what are the technical specifications required when one is setting up or buying hardware? For example, computers or laptops to be used in processing of drone data.
Okay. All right, we're looking at processing power. All right, so all right, there's no ultimate processing power that can allow you to have the most refined processing. All right, one is because when you're processing your data, it takes up different processing equipment, like components within your computer, right? You've got your RAM, okay, your random access memory, you've got your graphics card, you've got your processor, right? Those 3 components in the computer, they all play a part in terms of how fast you get to process your data, right? At one stage, where you are maybe the first stage of processing, where you're doing your arithmetic calculations, you might find your processor is the one which is really, really working hard, okay? Then when it gets to stage 2, where you are now trying to do your matching, key point matching, you find your graphics card probably is the one that's really working really hard. And your processor is now, it's probably at 20%, right? At the 3rd stage, you now find probably your RAM is the one that's now actually, shooting. So it would be advisable for you to strike a balance a bit, because it gets expensive as well if you want to invest in the best of all those things, right? But still, in the end, because the scale of your projects will still vary. If you have a computer that's able to process 500 hectares in a day, it means for you to process 1,000 hectares, it's 2 days, okay? For you to process 100,000 hectares, you're now looking at probably 20, 25 days. still, you will still feel you need to have less processing time for that 100,000 hectares. Now you want to expand on your processing again. So I think you just need to strike a balance, try and verify how big the projects you are normally getting at one time. If you are getting 500 hectare survey blocks, right, you can probably get away with the Core i7, right, 16 gig RAM and GTS 1650 graphics. Well, it's really difficult for to recommend the actual specs. Okay, but what you just need to know is you need to invest in your RAM, you need to invest in your graphics card, you need to invest in your processor. Okay, and you need to invest in your cooling system of your computer. It has to be really good at cooling, and you also need to invest in your internet. I hope it's really difficult for me to actually recommend actual specs, but still those specs will not be sufficient for 10,000 hectares. They won't be sufficient for 20,000 hectares. I don't know if you get what I'm saying, right? Yeah, but those are the three things you need to invest in.
Okay. The next question, it is asking if it is feasible to carry out farm subdivisions with a drone.
Okay. Yes and no. Okay. Why? Because in the end, you still need to physically have, beacons on the ground, right? So you've got a stand with four corners, right? You want to subdivide it into two. It means eventually you need two beacons in the middle, all right? So since you need those two beacons, it means a drone won't be able to establish those beacons for you. It won't be able to put in the pegs for you. So you still need to go back to to the basic survey principles, where you actually need to bring in control and you are able to, to put in those pegs, all right? But with a drone now, what you can do is for someone to determine where exactly they want to subdivide, all right? So you've got your area that you need to split into two. Sometimes it's not necessarily going to split in half. Maybe it needs to be split, depending on what structures are within the property. Okay. So what it means is you need to have an aerial appreciation of what is existing on the land, right? Then you decide this is where I'm going to be introducing my subdivision, right? So for planning, because normally the people who do subdivisions are probably who want the subdivisions to be done, they are not geomaticians. A normal person with their land in Crow Hill there, right? They want to subdivide, but the decision to subdivide for them is also based off of what they are seeing on the ground, right? And when they are seeing that diagram from the surveyor generals that they have with their title deeds, it's really difficult for them to decide, okay, this is where I want to put the boundary, and they have, the rest of everything going, the other side. Okay, so to help those guys to decide, I want to put my boundary here, it's really good for you to just for them to have the drone, for that drone imagery. Okay, and the good thing about having the drone imagery, it won't be too far off, because you're looking at 1.5 to 2 centimeters accuracy, depending on your flying height and also your geometrical accuracy of your sensor, right? If you have a survey grade drone, if you fly it properly, like in terms of the proper workflows, establish your GCPs, introduce RTK in your flight, fly low enough, process with those legit softwares, the platforms that I've told you about, you can bring down your accuracies to 1.5, 2 centimeters, right? Even your heights, they're really quite impressive, right? So for when someone actually eventually decides that this is where I want to be putting my beacons in my land, right? When you now want to translate those beacons into your total station and now come back to put in the beacons, you will still be within the acceptable, cadastral limits of 2 centimeters. Okay, so yes and no, depending on what stage of subdivision you are introducing the technology. Implementation and putting in of beacons, obviously no. Planning, right, and decision making on where to put the beacons, very much yes, you can.
Okay, I hope that was answered clearly. Then there's this question. Let me just read it as it is. It reads, my question is, what are the players in the industry of surveying and construction or civil engineering currently, maybe that person wanted to say you are currently working with? I heard he talked of farm subdivision surveys. He's working with the registered land surveyors when it comes to lodging a DSG.
Okay. Well, we...
And sorry, then on that same question, it's written, last question is, how is Ironmask market share like?
Okay. All right, I'll probably start with the first question. All right. We are not doing title surveys. Okay. We are not doing title surveys. Those are for professional land surveyors. Okay. But what happens, like I initially highlighted, at what stage does the work need to be done? Okay, if I explained that I can use drones for decision making and planning, right? For the end user, right? For them to be able to appreciate where they want to subdivide. Okay, they need that spatial data. They can do with topographical surveys, right? They want to know which side is the best to put buildings, right? Which will also govern how they are going to be, distributing their land. Okay, so topographical detail would be good for them. I can do that. We can do that. Okay. What else? Digital surveys, aerial mapping, and all those things that they will use to decide where to do their subdivision. We can do it. Okay. But what happens now is, after we've done it, they will now say, now I want it to be subdivided. That's when now we have those professional land surveyors coming in to do the actual subdivision. Then they do all the final lodging of documents with the DSG. Okay, then they give the client. All right, so that's to do with the subdivision part. All right, so we are not doing subdivisions. We are not lodging any subdivision documents. We are not professional land surveyors, but obviously we've got professional land surveyors that we are working with. Right, we get a project that needs them to do, we'll come in, they can do it. They have a project that needs us to work on, we will also do it as well. Then in terms of the first question, to do with other players in the industry of surveying and civil engineering currently working with, I'm not sure if they were asking who we are currently working with or what other players are currently working with, I don't know, using drones. Or maybe they can clarify that question, then I can be able to actually respond to it really well. All right. Then with regards to Ironmask market share, I wouldn't be able to respond to that, okay? Because there's no statistics really. All right. Like I said, the industry is still new. Information on the industry is a bit still, all over the place. Okay. No one really knows how much is it, how big the market is, okay, and how big the services are, because we're also covering a large spectrum of services. We are into mining, we are into construction, we're into property development, anything that a drone can do. So all those are different markets that we will be looking at. So also the question will need to be direct: market share in mining, market share in land surveying or engineering. But also that would be really difficult to say, because there hasn't been a study into the statistics regarding to the market that is available in Zimbabwe for the drone industry. So that's another industry for somebody else to go into. Those guys who are into statistics, if they use it, they can find work in collecting that statistics and also helping us determining the market share.
Okay. Because of our time, we don't want to exceed 3:30. So I think we can go on for about 11 more minutes. There's a follow-up question, which was saying, isn't it drone technology is better on curvilinear boundaries establishment, that is rivers and railway, and old township surveys with existing physical boundaries. Our elders are resistant on using drones, hence I ask.
Okay. Well, obviously, how he presented the question would suggest he actually knows the answer to that question. Okay, but well, maybe just to support him there, on curvilinear boundaries, yes, the drone technology will be really good. Okay, because obviously you've got more continuous data, unlike when you're picking individual points within, on a curvilinear boundary. It means there is a lot of interpolation that's happening. Okay, the drone technology would be really good for the curvilinear boundary surveys. Okay, I think what the issue with there being some resistance in using drones for certain types of surveys is mostly to do with there not being us not having done experiments of proof of concept surveys, which is something that we probably need to come together as an industry to say, okay, we don't want to be backward. Okay, we want to be, to go ahead in adopting these technologies. How best do we make sure that these technologies are good for us to be using for physical boundary surveys? Okay, we cannot just dismiss them without actually having tested the technology. All right, so we can have the old ways of doing surveys being done in a certain area. Okay, we bring in the new technology, we do it. We are very much open to doing it because we are also advocates for really accurate and good data. Okay, so we are open to joining hands with even Zig. You guys, I know you've got your the education department. Maybe it's also time we have a research and development branch in the geomatics industry. Okay, where we do all those kind of researches, we develop documents that speak to where this technology can be used and where it cannot be used, because we are basically just dismissing it without having done experiments to prove. Okay, so yeah, I think that's my thinking in the way forward with regards to how we should proceed with this technology. And also you might find this is just my thinking. Sometimes we have accepted, okay, the accuracies of like, let's say for instance, for cadastral surveys, we have accepted those accuracies to be within 2 centimeters. All right. I think it's also high time we also ask questions like, is 2 centimeters really, necessary? Okay, because in the end you find, okay, we've got 2 centimeters accurate, but in the end we've got people building up dura walls that are 30 centimeters thick. All right, meaning people can tolerate a 30 centimeter encroachment within property. And if you have a 30 centimeter encroachment within somebody's property because of a dura wall, and a drone can do 5 centimeters accuracy, it means we can still do cadastral surveys with, with drones in areas where there are existing boundaries. So it's not a matter of just dismissing, it's a matter of rethinking, re-justifying some of the methods that were being done before, and moving forward, because now we're in an age where things are moving fast. People want fast data, people want fast turnaround times, and drones can do that for those guys and also bring in new value. So yeah, I don't know, it's something that we can discuss about later on, see how best to go about it.
Thank you very much. A lot of questions coming up, but we are listening against time now, so I'll probably just entertain last 2 questions, the ones that I have with me here. It reads, can you tell us about team structure? How do you work from flight planning to the end product? Who does what, and what are the professional qualifications that are involved in each role?
Okay. Let me see how best to respond to that. Okay. Within a team, the regulations, I'll talk of the regulations because that's what the law requires. Okay. So the law requires, if you're going to be doing a corporate, a commercial operation, you need to have someone responsible for okay, within your organization, because obviously you're going to be encountering a lot of safety and health incidents. It's an engineering kind of setup, right? You've got batteries which are explosive. You've got, you know, power and electricals and everything. So there is need for you to be observing some form of, you know, SHE. Okay. They also require that you have a qualified maintenance guy, right? That means you have someone who has done electronics, who has done aeronautical engineering, you know, all those kind of things. So it means they will be able to maintain your aircraft to standards that are required by the law, all right? Then you need someone who actually just has a license, right? Someone who's able to fly, right? Depending on what kind of operations you need to be doing, all right? Whether it's beyond visual line of sight, within visual line of sight, you need someone who can fly, right? And who the law recognizes they can fly, to indemnify yourselves if anything happens, right? And also to make sure that you're flying properly, right? At least if you can have not just one person who can fly, at least if you can have 2 to 3 people who can fly, because whenever you're operating an aircraft for commercial reasons, you are not supposed to be operating that aircraft individually, right? You need someone who's observing, who's looking out for you to see if there are any hazards, right? Someone who's spotting hazards, or someone who's documenting your logs and everything, all right? So it means you at least need 2 people, right? Really, at least 2 people who are able to fly, to operate the aircraft. Then but in terms of operations, those are the people you need: maintenance, safety and health, your pilots, okay? Then from the process of flight planning until you deliver, you're now looking at your pilot to be involved in your flight planning, because obviously they know how they're going to be flying it. Since they're going to be the one who's flying, they need to be involved in the flight planning. You need your maintenance guy to tell you and advise you whether you're stretching the aircraft too much in your flight planning, whether your aircraft is going to be able to do it, right? Then you need your SHE guy to be telling you what protocols you need to be observing, which takeoff points are, you know, off limits because of certain SHE related issues, all right? Then once you are done, now you need you go into flight where you need your pilots and your geospatial, your geomaticians rather. Why you need those guys in the field is because they are still going to be coming back to the field, to the office, to process their data. Geomaticians, EIS guys, or geophysicists, depending on what you're doing. You need those guys because you need to know, they need to understand the field for them to be able to interpret the data in the office. I don't know if you have experienced a situation where you just get data in the office, then you fail to translate it because you were not in the field, right? So that's how it works. Then you come back into the office, you've got your GIS people. Depending on the end use of the data, you might need people who have done environmental studies. If it's an EIA related data collection, you know, process, or you need your GIS guy to do the data processing. You still need your those guys who are really good at land surveying to do the processing of data, because at some point you're going to do coordinate conversions, you're going to do interpretation of elevations, profiles and stuff. Land surveyors are really good for that. Civil guys will really be good for interpreting and, you know, documenting civil works information. So well, the spectrum is really large depending on the end use, but basically I can say that's the skeleton of what the structure would, what a perfect structure would look like.
Okay. Okay. I hope Tonga, that was Thomas' question right there. I hope she's been answered clearly. Then I think we should just wind up now, and maybe you can tell us your best experience or your worst experience in the drone industry.
All right. Best experience. All right. I think my best experience is dealing with new drone technology. It's always exciting. I think I've been flying for for almost 3.5 years now, but every flying experience has been really amazing, right? You learn new things with every experience, right? You go to the lower veld area, then you realize your drone has issues flying in high temperature environments. Okay, then you go to Nyanga, where the wind is really high. You then realize your drone cannot fly within winds of 8 knots, above 8 knots and stuff like that. So it's a learning experience. You can never really say you know everything in terms of flying. All right. So the best experience for me has been the actual flying of aircraft using the new drones, especially the big ones, the 10 kg kind of drones, and also getting that exposure and experience of using the different tech, obstacle avoidance, and all those kind of things. So that's my best experience. I think the worst experience has been the learning bit of it, which is where you've got all the drone crashes. You've got incidences where the drones crash. You've got incidents where you get bird attacks from a bird attacks your drone. It's unsettling even for your it's a bad experience, right? But all I can say is the bad experience has been a learning curve. Now you know what not to do. You know how best to avoid those kind of scenarios, because you don't want to be losing your equipment. It's really expensive equipment, and you need to make sure that you have all the dots that are ticked off and all the check boxes ticked off before you fly. And after you fly, you can get home to some good night's sleep.
Okay, thank you very much. That was very enlightening. We have learned a lot. My very, very last point is, can you share with the Zim young surveyors out there, can you just give them 1 or 2 words of encouragement and just to prepare them for those who are interested in getting involved in the drone industry?
Okay. First of all, I think you need to start thinking as if there's no box at all. Okay. You need to be open-minded. Don't have your blinkers. You have people always complaining, surveying that. I think it's a mentality of not wanting to be innovative. Okay. Yes, we are geomaticians, we are land surveyors, but that's not what we are, entirely. We are also people with needs. We are people who want to make money. We want to live. Okay. So what that means is, do not just be thinking with blinkers to say, I am a land surveyor, so I want to be on a total station. I want to be operating a drone, right? Sometimes you don't even have to be able to operate a drone for you to be in the drone industry. All right. You probably just need to be there for consultancy, for guidance. You can be in academia where you are now training people on drones, what the drone technology is bringing in. So my word of advice is just look out for opportunities, right? And don't be, just thinking that there is only one way to go when you're done with your land surveying or GIS degree. Then you're thinking that's all there is, right? There is so much to do in the industry, like the consultancy bit. Just look out for what to do, right? Like I said, the drone ecology is really wide. You've got the retailers, you've got what do you call it? You've got the pilots, you've got the land service providers, you've got bankers even coming into the industry. So just keep your eye out on what next. What is going to be coming next in terms of the technology. Already now, the good thing about Zimbabwe at the moment is everything is out for you to take it, all right? Unlike developed countries where everything is structured and where everything has somebody who's doing it. In Zimbabwe, there's so many things that are not working, where if you introduce yourself, if you apply yourself in those industries, you will be the next best person in that, right? So think about the challenges that we're facing in getting drones into Zimbabwe, right? Be the person to bring those drones. think about the challenges we are having in fixing our aircrafts if they crash. Be the next person who's fixing those aircraft. Okay, so don't always think because everybody is doing drones now. I also want to be doing a topographical survey with drones. The market will be flooded with people doing the same thing, whereas there are other open avenues, right? People are now doing broilers. You go into broilers as well. But for the broilers, you can be the person who's supplying the drugs, that are needed. So just think about how you can support someone else who has already started. Okay, what would they need? They need insurance for their drone. Okay, I'll do drone insurance. They need space for their drone, or I'll supply space. That kind of thinking. So the youngsters need to start thinking on where the next opportunity might be and how best to go into it. So yeah, that's my thoughts.
Oh, thank you very much. It was really good to have you on this platform. So thank you. We have learned a lot, and I hope those who were participating with us on this platform led to those who are going to watch the recording of this session as well. Thank you, Mr. Mafara, the drone boy, for delivering. We have learned a lot. Thank you, ladies and gentlemen. We can call it a day. Look out for more GeoChat sessions that we'll be having in the following weeks to come. Good day.
Thank you, guys. Have a lovely day. Cheers.
Thank you and good day.
Thank you.
You're welcome.